So in this video, we're going to talk about an end behavior of a polynomial. What does that mean? So that means that what if I had, say, a polynomial, right, say x squared. So this is, say, a quadratic polynomial, not necessarily x squared. But as I go towards infinity, right, as I take my x values and I go towards infinity, what happens to y? You see that this function increases in the positive direction up to infinity. There's no bound on this function, it keeps increasing. So we'd say that as x approaches infinity, this function fx or y also approaches infinity, right? And same way as I went towards x in negative infinity in the other direction, then I would say that y also goes to negative infinity. So we're going to look at how can I determine that for different polynomials what their end behavior is, and that's what we're going to do in this video today. So let f of x equals an x to the n plus an minus 1 x to the n minus 1 plus and so on until a1x plus a0, where obviously an is not equal to 0, be a polynomial. All right, then an x to the n is called the leading term, and an is called the leading coefficient. Okay, so looking at a leading term, we can figure out, and the leading coefficient, we can figure out whether this function would go towards infinity or would it go towards negative infinity. So let's look at it. So case 1. Okay, that is n is even. So if n is even, you can think about this function in terms of x squared. That is, as I go towards infinity, as I make my x values really big, this polynomial function for an even n would work just like x squared. It would behave exactly like x squared. So now part 1. If an was greater than 0, then as x approached infinity, y would also approach infinity. Okay, that is, as I go to the right, my function would go up. All right, and as x approached negative infinity, y would also approach infinity. So like I said, think about x squared. As I go towards the right, my function is going up, and as I go towards the left, my function is still going up, right? So my polynomial, it won't be exactly like this, but the end behavior, right, what happens as I go towards infinity, the end behavior will be the same as that of x squared. Okay, well, what if an was less than 0? Then if an was less than 0, this in case of a quadratic function, this would open upside down, right? It would go this way. So let me draw that in red. Right, this would actually go down, which means it doesn't matter which way I went. If I went to positive infinity or negative infinity, my function values are going towards negative infinity, or they're going down. So as x goes to infinity, y goes to negative infinity, and as x goes to negative infinity, y also goes to negative infinity. Okay, now what if n was odd? Well, if n is odd, then you need to think about the function x cubed, right? The function x cubed looks something like this. That is, as I go towards positive infinity in the x, the function rises up towards positive infinity, and as I go to negative infinity on the x, the function falls down towards negative infinity, right? So again, two cases. If an is positive, then as x approaches negative infinity, y approaches negative infinity, and as x approaches positive infinity, y also approaches positive infinity. So x and y sort of go in the same direction in that sense. Okay, and then for number 2, if an was less than 0, then I would have the exact opposite behavior. So if I had, this function would now look this way. So as x went to positive infinity, the function would fall towards negative infinity, and as x went to negative infinity, the function would rise up towards infinity. So I would have then, as x goes to negative infinity, y goes to positive infinity, and as x goes to positive infinity, y goes to negative infinity. So that is how we describe the end behavior of the function. I'm going to let you guys look at it for a second. So in this video, we're going to look at how to determine the end behavior of the polynomial, which is negative 2x cubed plus 3x plus 4. Right? We looked at the previous video where we had a theory-based determination of how I can figure out, by looking at a and looking at n, I can figure out what the polynomial behaves like. Right? So here, if I look at my leading term, this is my leading term. It's negative 2x cubed. Okay? So this is my n and this is my a. So first thing I notice is n is odd. Okay, that is, it is 3. And the second thing I notice here is a is negative. So, which means it's going to behave like negative x cubed. That's going to be this way, right? That's my end behavior. Down here in the middle, the behavior might be different, but as I go towards infinity, these functions will behave in the same way. And so I know now that as x goes to infinity, y is going to go to negative infinity. Okay? And as x goes to negative infinity, that is in this direction, y is going to go to positive infinity.